Okay, so what you're seeing a video now is a video of how I would use plop whenever making the mirror cell for a 16-inch telescope. So we'll open up plop. You can download that. It's freeware online. Just Google search it and install it into your PC. Now, if you have a Mac like I do, you're going to have to use a virtual Windows runner, which is what I'm doing right now. So what I'll do is I'll open up plop, and on the first page there's an automatic cell design button. What I'll do is click that. In pops this second box that wants to know the diameter, thickness, focal length of the primary, and then also the diameter of the secondary mirror, and then the central hole. And of course there's not going to be a central hole because this is a Newtonian reflector. So 16-inch mirror, I'm going to enter in millimeters. It's 406.4. And then the thickness of this particular mirror is 41.275. The focal length, of course, you know that if it's a f4.5, you would multiply that by 16. 4.5 times 16 is 72. Multiply that by 25.4, and that gives us our focal length in millimeters. So after we've entered all that, and then also the diameter of the secondary mirror, I am going to click Next. How many points do we want? This is going to be an 18-point mirror cell. Of course, if you're doing a 12.5-inch mirror, you could do a 6 or a 9 point. So I don't want the angles to vary. I'm going to keep it simple. We're going to hit Done. Now we want to go down here and just hit Start Plot. Execution completed. All right. So now I'll go up here to Graphic Plots. Let's look first at the cell parts. So that's what our 18-point flotation mirror cell is going to look like. Now what's great about plop is it also gives us our exact part dimensions. I can change that to inches to make it easier. So there's our triangles. Now what you can do whenever you're first starting out, if you're not doing and you can make this very, very accurate by doing it this way, is just look at those dimensions. You can either print them out to scale, which isn't too awful hard to do, or you can just use graph paper and draw it on a graph paper. Each of those points is where the point needs to be that's going to be touching the back of the mirror. So you would just make your triangle slightly larger than this. And then this is where that central hole is going to be. That's going to have a bar that connects these two together. So let's go down and let's look at our bar, because this also gives us the length of our bar. I don't want antivirus, please stop. Okay, so our bar is 5.125 inches long. Then of course the middle point is going to be 2.562 inches. Of course, so if you think about your mirror cell, we're going to basically have two bars that support 3 of these bars for the mirror cell, 2 crossbars that go across the bottom of the mirror box. So there's going to be 3 holes in the 2 bars, and that's going to be the central hole that comes up through that bar. And then of course that point and that point is going to be where the triangles will sit. And so I would just drill a 1/4 inch hole in those triangles, and then a 1/4 inch hole right here in these bars, and then we'll put a 1/4-20 bolt through there, and we'll have it just right on a simple nut, and that's going to be our flotation point right there. And so this is how I get the dimensions for our mirror cell. So I'm going to go ahead, just want to kind of show a video of the computer aspect of it. I'll go ahead and get these printed out, and I'm going to start cutting the aluminum today. Okay, so more on the mirror cell. Now what I've done is, as I showed you with the plop program earlier, I took those part dimensions, I transferred them to graphing paper. Okay, so we have our bar that's going to hold the triangles, and then we have the triangle. Now what I'm going to do with these is I'll take some 2-sided tape and just a small piece of a 1/4 inch MDF, and I'm going to tape these on here, and then I'm going to make a template. I'll cut these out, and that's going to be my template that I'll use to transfer to aluminum. So we'll do this real quick. And actually, we don't have to film all this. Anyway, I will transfer these on, and then I will take these over to the bandsaw, I'll cut these out and then I'll show you how I put these onto aluminum. Okay, now what I have here is 3/16 inch thick, just sheet aluminum. Pretty inexpensive. You can get this on eBay or Amazon or other places. You won't need a whole lot because I just need 6 of these triangles. And then I'm going to use 1/4 inch thick for the bar stock. So again, I just transferred the patterns onto MDF. I cut that out with plywood and then I taped it on. And then I numbered 1, 2, and 3 just like it's numbered on plop. What I'm going to do before I drill any holes or anything like that is I traced an outline onto the sheet aluminum and I'm going to cut it about 1/8 of an inch big on the bandsaw. Just rough cut it with my hands. So I'll do that really quick. One bandsaw tip I'll throw in when you're cutting aluminum. Now if you don't have a bandsaw, just use a jigsaw and go very slow. But wax your blade. If you just use regular old, not a paste wax, but a paraffin wax, get this at a drugstore or something. Just hit your blade with this. It makes the aluminum a lot smoother cutting through it. So we'll get started doing this. Okay, so here we have 6 very, very rough cut triangles. Now, if you don't have a bandsaw, you're probably not going to be able to do, well, you're not going to be able to do the jig I'm about to do. And that's the reason I cut it slightly larger, because I've got a jig that's going to get within about 1/16 of an inch of this exact shape. It's pattern cutting on a bandsaw. I enjoy doing it, and it's a good, precise way to do it. Then I'll take this over to the disc sander and just slightly sand it down. So if you don't have a bandsaw, just use a jigsaw. Go real slow. You know, you want it to look as good as possible, and then you want to take it over to a sander and sand it down. And this doesn't have to be aluminum. You could use 1/4 inch plywood, works excellently. So 1/4 inch plywood would substitute this just fine. Just make sure your bar, if you're using plywood, for the bar itself, I'd use at least 1/2 inch, maybe even 3/4 inch, and make sure it's about 1 inch wide so that whenever you put the hole in the middle, you don't lose a lot of that structural integrity. And I use aluminum just because it's, it looks very professional. It powder coats nicely, and that's what we provide with the scopes. But you could absolutely do plywood. So next I'm going to set the bandsaw up with my pattern cutting jig, and we'll film that. Okay, so now we'll start pattern cutting the aluminum. So this is my very fancy pattern cutting jig on my bandsaw. I just use a really fine tooth blade, and then I've got a piece of MDF here with a small notch, and then I've got the corners rounded so that as I push the MDF pattern along here with the aluminum tape to the top, it's going to cut the exact pattern. So I'll film doing one of these, and then we'll just shut this one down. This is my clamping system that I made, just a temporarily thing. You can see how it bends the wood, but it holds this nice and tight, which is the important. There you can see I used some two-sided tape, taped the pattern to a piece of aluminum, and we'll go ahead and cut it out. Okay, so there's the pattern, and there's the cutout. So as you can see, it leaves kind of a rough edge here, but other than that, it gives you just about a perfect pattern every time. So that's my favorite way to do the aluminum triangles, unless we're having them laser cut, which we also do. So what I'll do now is I will untape that. I'll put the pattern on the next triangle. I'll finish those. I'm also going to do the same thing with the bars, except instead of the 3/16 inch aluminum, I'm going to use 1/4 inch aluminum. So I won't film all of this. I will, next video, we'll just show that I've got all 6 of these and all 3 of the bars cut out. We're going to work on sizing the frame of the mirror cell itself. So that'll be the next video.